Okay, so let's see what is coplanar and non-coplanar. Just imagine I use a cube. The cube is one where we can show different planes, right? So this is one plane. This is another plane. So we can see at a time 3 planes, right? So cube is a system where we can see all planes. So we are going to use those same plane. Okay. Now, what is mean by coplanar? Means all forces will be in same plane. Okay. So all forces will be in same plane. And what is non-coplanar? If I want to show it, it is very simple. So forces will be one force in this plane, another force in this plane, or another force in this plane. So from here, what we understand, what is mean by a coplanar means in one plane, and non-coplanar means in different plane. Means forces are present in different planes. Why we need to learn this is to understand the force system acting on these bodies. Okay. Now we have this coplanar and non-coplanar again classify into 3 types, and those 3 types are similar to each other. Okay, first is a concurrent, second one parallel, and third one non-concurrent and non-parallel. How to represent this type of force system, I'll show you. Okay, so this is one plane. In that plane only all forces will be there. So what is mean by concurrent? So all forces, when the line of action of all forces in a system passes through single point, means like this force, this force, this force, this. So if you extend the line of action of all forces, then it passes through one common point, then these all forces we can say as concurrent. Another system we will draw. Okay, so now we will define what is meant by parallel. So parallel means the forces are aligned in a such a way that the distance between the two forces will remain constant. Okay. Now this parallel also again classify into 2 types, that is like and unlike. What? Like and unlike. So like means what? I'll show you. Like means both forces, if I consider only 2 forces or 3 forces, so all 3 forces are in same direction. And what is mean by unlike? Unlike means what? They are parallel, but their direction is not the same. Okay. So what we classify, how we classify our forces? First, coplanar, non-coplanar, concurrent, parallel. Okay. In parallel, like, unlike. Now again, non-concurrent, non-parallel. That means this type of forces are like this. Okay, so these are not parallel also and non-concurrent also. So this type of system is called as a non-concurrent and non-parallel. On similar basis, we can classify again non-coplanar in same direction. Only I will not do that. Okay, concurrent, parallel, non-concurrent. So only difference is these forces will go like first concurrent and non-coplanar. So now what will happen? I can show force like this, like this, like this. So all three forces are in different plane, but they are concurrent. So this is concurrent and coplanar, non-coplanar. Again, next concurrent, sorry, parallel, and so this is one parallel, another force is here. So these are the parallel forces. And if you want to say non-coplanar, non-concurrent, so we can see this force. Okay, so this is how force system is classified. Have you understood it? Okay, so now we understood how force system is classified. Now, what I have to do is just imagine there is one big box, okay, and Scarlett is not there. Yeah. You know him now. Uh-huh. Just check Scarlett, or else he sit on first floor. Okay. Sorry for disturbance. Yeah. So when we say force, there are different forces. Okay. So what different kind of forces are there? So just imagine okay, so this three men is pushing this box, heavy box, and they want to move this box from this position to this position. Okay. Now, now, instead of all these three people, if I replace those three people by a one person to do a same work, to do the same work, okay, he is bodybuilder, so he can do that easily. Then this person, what is doing? This person is doing the whatever three people are doing. That means three people forces is converted into one. Okay, so what we can write that this is like a resultant force. Okay, and resultant force is a which we can define which can replace the given force system. Means instead of all forces, it will be the single force which will replace the number of forces within the system. Okay, now I will tell you different type of forces. So another is a tensile force. Okay, so now if one rod is there, okay, and it is pulled by two people, okay, it is pulled by two people in this direction, then this bar is under tension. Okay, and that force is called as a tensile force. That means like a pull. If body is fixed at other point and if you try to pull that body, then we can say it is a tensile force applied on that body. Okay, now is next type of force is called as a compressive force. Okay, so what is mean by compressive? Similar on similar basis we can write. Only thing is that instead of pulling that bar, now these two people, what they are doing? They are pushing this rod towards each other. That's why this is called as a condition of compression, and this force is called as a like this is called as a compressive force. Uh, Everyone please note that if we are doing online lecture, we are in online lecture, then what you have to do is you have to write small notes or wherever important points we come across, then you have to write it. Okay, now this is another type of force. Then there is another force. Just introduction we have to go through it. So shear force, like if you move your hand over this box on the top layer, then whatever force apply that is parallel to the surface, okay, or tangential to the surface, then that force is called as a shear force. Okay, so important three forces: tensile force, compressive force, and shear force. Okay, and what is resultant force? It is a single force which represent a force system. Now in mechanics, what we have to do is we have to do two things. What two things we have to do? First one is a composition of forces. And second is resolution of forces. Okay, whole engineering mechanics or first two module is based on composition and resolution. Now, what is mean by composition of forces? So, in composition of forces, forces may be combined to obtain a single force which produces the same effect as that of a original system of forces. Like I told you earlier, like one book is there, okay, and this book we need to move. So there are number of forces which are acting on this book, okay, and this all four forces acting so that this book move to the from left to right. Okay, so if we replace this all forces and by a single force and we get the same effect, then we can say that it is procedure is called as a composition of forces, and that single force we are getting is called as a resultant force. We already defined, right? So what actually we are going to do is instead of these four forces, we are going to replace those four forces by using only one force and the effect remain same, then that single force is called as a resultant force. It is denoted by capital letter R. Okay. So what is resolution? That I will explain afterwards. Okay. So resolution is nothing but this whatever one force is there, it is divided into number of forces. So in composition of forces, we have different laws which can be used to add all forces. Okay. So what is the first law? First law is law of parallelogram. Of law of parallelogram of forces. Okay. Now what is law of parallelogram? This will discuss. Okay. Now first I will write a statement. Okay. If two forces acting simultaneously on a body at a point, just see, if two forces, if two forces acting simultaneously on a body at a point are represented in magnitude and direction. See, because this is a vector, so are represented in magnitude and direction by two adjacent side of by two adjacent side of parallelogram. Don't worry, this is not difficult. The statement looks like big something we are doing. Then the resultant, then the resultant is represented again by magnitude and direction by the diagonal of parallelogram, which passes through which passes through the point of intersection. Okay, what it represents, if two forces acting simultaneously on a body at a point are represented in magnitude and direction by two adjacent side of a parallelogram, then the resultant is represented by diagonal. What is resultant force? I already explained. Resultant force is nothing but a force which will a single force which will replace the force system or number of forces. Okay, so let's do it. Let's consider two forces, this one and this. You can consider at any direction. These are the forces, so I give P bar and Q bar. Okay, these two forces we can represent by two sides of parallelogram. So let's represent with magnitude and direction. So we will not change its magnitude and we will not change also its direction. Okay. Now if I see these two forces are far from each other, but I told you along the line of action, you can show that force anywhere, right? Like this force can be shown like this also or this also. Okay. So along the line of action, if we show the force, then effect will be same. Okay. So that is called as the transmissibility of force. Now, what is they are saying that two forces, अरे, क्या हुआ? हाँ, two forces are represented by two sides of parallelogram. Okay. Now we have to parallelogram means sides are parallel with each other, angles are not 90 degrees. So now let's complete the parallelogram. Okay, we have completed it. This is P bar, this is Q bar. Okay, this is P bar, Q bar with direction and magnitude we have represented. Now, what we have to show is that these two forces are having magnitude and those diagonal passing through these two forces will be the result. Okay. Now, what for to show it, what we can do is now you know these two are see this P force, this and this is similar. Okay, what I will do, wait. So this is also P bar. Okay, in magnitude, and this is also Q bar because these two are parallel and direction is also same, magnitude also same. Right. Now what I am going to do is to prove that this resultant, I will draw a resultant or diagonal. Okay. So what they are saying, this diagonal, whatever I have drawn, will give a resultant force for the two forces, that is P and Q. Okay. So for to, what you can do is to prove that, what I am going to do is I am going to put a perpendicular okay, on at a corner. Now let's consider this angle as alpha and this angle as theta. What? This one angle as alpha and other angle as theta. Okay. Now I'll give a name to this system. I will give name is as O, A, B, C and D. Okay. So in triangle ODB, which is the triangle? Just see this triangle. In triangle OD and B. Okay, what is the triangle? ODB. This is 90-degree triangle, right? So we can use which theorem? Pythagoras theorem. What Pythagoras theorem says? Square of two sides is equal to square of its diagonal. So if we consider a triangle, OEB, we can write OB, that is diagonal, square is equal to OD square plus DB square. Okay. Now this OD is consist of two parts. You can see here. It is consist of first part as OA, another part as AD. Right. So we can write instead of OD is addition of two parts, that is OA and AD. So OA plus AD bracket square is equal to DB bracket square. Now we know that what is OA? It is of which force? Force E bar, right? So we can write OA as, we can replace OA by force P. Okay, plus what is AD? Now we will draw again the same triangle. Okay, just consider this triangle. Okay, so triangle, if you consider ABD like this. Okay, this is AD B. This angle is theta. Then what is sine theta ray? And what is cos theta? Yeah, I will allow you to speak. You can't speak. Now you can speak. I allow you. So you can unmute anytime and you can speak. So sine theta is equal to what is front side divided by adjacent side. So BD divided by AB. And what is cos theta? Cos theta is adjacent side, that is AD divided by diagonal, that is AB. So what we can write from this equation? AD is equal to AB cos theta. But what is AB? You know that this is Q force and this is also Q force, because those are parallel and in same magnitude. So AB is equal to Q. So instead of writing that, we can write AD is equal to Q cos theta. Have you understood this? Yes. Then what we can do, we can replace this AD by Q cos theta. So let's replace Q cos theta bracket square plus DB or BD. So what is BD here? So BD is equal to AB sin theta. And again, what is AB? AB is nothing but Q. So Q sin theta, right? So replace that in here equation. So what is DB or BD? Q sin theta bracket square. Okay. Now what we will do? What is this? Which formula it is? E plus P bracket square, that is equal to A square plus 2AB plus B square, right? So same formula we can use here for these two terms in bracket. Let's use that. So it will be the answer P square plus 2PQ cos theta plus Q square cos square theta. See what I have done? First term square, second term square here, and remaining is 2 into the terms plus Q square sin square theta. Okay, now what we can do, P square plus 2PQ cos theta is equal to plus, now see, Q square and Q square I will take common, Q square I will take common, so remaining cos square theta plus sin square theta, right? And what is that? Cos square theta plus sin square theta, it is equal to
1.
yes. So automatically we can write P square plus Q square plus 2PQ cos theta. From where we started, it is OB square. What is OB? OB square. What is OB? We represent it by letter R. So R is equal to R square is equal to this. So instead of R square, we can write R is equal to square root of P square plus Q square plus 2PQ cos theta. So this is final, we can say, magnitude of resultant. That is R is equal to what it states. If two forces are there, if they are represented by a parallelogram, then the diagonal passing through them will give a resultant. Okay. Now let's consider another triangle. So this angle, whatever angle is alpha. Okay. So what is tan alpha? If I consider triangle OBD, then I will not write here. It will be more confusion for you. So tan alpha is equal to, just see the triangle. Tan means what? Opposite side divided by adjacent side. That is BD divided by OD. Okay. So we can write tan alpha is equal to, sorry, tan alpha is equal to BD divided by OD, or you can write BD divided by this OD we already used. It is consist of OA and AD. So OA plus AD, sorry, yeah. So this BD already we calculated earlier. BD is equal to Q sine theta. OA is P and AD is Q cos theta. Okay. So tan alpha is equal to Q sine theta plus sorry, divided by P plus Q cos theta. Okay. So this is angle between the resultant and any one force. Okay. Now I forgot to tell you one important thing. I think already it is maybe some professor already told you that you when you enter into engineering, first thing is important you require is what is this scientific calculator. Okay, so now your question will be there are so many scientific calculator are there, but which you should take. So Casio company comes with different numerous calculator. Okay. So now new series they have come up with FX series. Okay. So FX or ES series calculator you can buy. Okay. And just go through which calculator do what thing. Okay. So any one calculator you can buy. It is around 1,000 rupees one time investment, and once you purchase it, it will be like throughout your life. It will remain with you. Okay. So out of these two series, don't take any programmable calculator. Just whenever you are going to buy calculator, don't say that he may give you a programmable calculator. So they tell them, I don't want programmable. I want only simple scientific calculator. Okay. So why it is required? Because we are going to solve new problems, right? And those problems, if you want to solve, you need calculator. Without calculator, you can't solve. Now see, I forgot, like literally forgot, and now we are going to solve some problem, simple problem, right? So to solve such simple problem, now we don't have calculator. But for now, what you can do, you can use your mobile phone. But please, it's my request. No, anyhow, you have to need to purchase that calculator to do engineering from first year to last year. Okay. So some people, what they will do, they will wait for 10 or 15 days and they will say, I will buy afterwards, or I will wait for Amazon sale or Flipkart sale. Don't do that. Hardly 50 rupees will be difference between shop and online. You can check online also. It's no like offense or no problem. But my thing is, it should you should get it as early as possible. Okay. Done. So we'll continue with. So numericals will solve during next lecture, online lecture. So I will show you another thing, that is representation of force system. Okay, so have you used two-dimensional axis? Graph have you plotted anytime in your life from your school to till this point? Yes, you have plotted many times, number of times. So you know that this axis is called as a x-axis, horizontal, not every time, but normally like a hand rule, it is we follow it as x and this as y. This side is positive x-axis, this side is negative x. This side is positive y-axis and this side is negative y-axis. So this graph, what we used earlier, is classified into different quadrants. Okay, so this look like one quadrant, right? So I divided this whole sheet into 4 parts. So this is called as a first quadrant. This is called as a first quadrant. This is called as a second quadrant. Then this is called as a third quadrant, and last one is called as a fourth quadrant. Okay, so why these quadrants are given to represent the force system. Now I will tell you how. I will show number of forces here. Okay, A, B, C, D. Okay, A, B, C, D. So all these forces are represented by names. Okay, now this all forces you can represent or represent in this quadrant system. Okay, so if you say force A, force A is directed towards which quadrant? Towards which quadrant? First, second, third, fourth. Just see this, it's arrow.
First.
Yeah, so it is in first quadrant. B is in towards the fourth. C is towards the third, and D is towards the second. Okay. Sorry. Now, as we know, these are the axes. Okay. And our sign convention to solve problem, always remember sign convention like this axis. Towards positive x-axis, force is called positive. Towards negative axis, force is we will consider negative. Upward, positive. Downward, negative. Don't worry, I will explain how it is. First, you purchase calculator before a next lecture. Okay. Now, we already studied what composition of forces. Like that, we can resolve the forces. How to resolve the forces? Okay, it is very easy. I'll explain. I will explain those forces one by one. Now we'll consider a parallelogram law. What are the two forces? They are represented by E, Q, right? P, Q are the two forces, and their resultant shown by diagonal. Now, what we are going to do is first of all, what is theta? That you should understand. Theta, now see, this is a Q force and this is a P force, and this is a Q force and this is horizontal. So this is angle is theta, right? So this angle also will be automatically theta. Why? Both are parallel. Both angle included by those two lines, those are parallel to the each other. Okay. So what we understand from this equation, that resultant is equal to square of one force, square root of square of one force, square of other force, plus 2 times product of two forces and the cosine of angle included between them. Angle included between them. Now, just imagine if two forces are perpendicular to each other. E, what will be the angle included by these two? 90 degree. Okay. Now we will use our formula. Resultant is equal to square root of, what is that? P square plus Q square plus 2PQ cos theta. And what is cos 90? What is cos 90? 0. Okay. What is cos 90? 0. That means what is R?
0.
Yeah, R is equal to square root of P square plus Q square. And how that resultant is represented? Just complete this. So this is the resultant. R. Now, if I give any force here in your quadrant, then you can resolve that force into two components like horizontal x, horizontal y, horizontal x, horizontal y. Okay. So that we are going to learn in next lecture. So today, this is, I think your attendance is going down like last 5 minutes. It is coming to 36. Yeah. It was earlier 53, 54. So now it is slowly reducing. Maybe continuously online lecture. You can see those recorded lecture here. One query or feedback I want from you. Whatever I'm teaching online, is it okay? Whatever platform I am using, is it okay to draw?
Yes, sir.
Yeah, to draw and all those things. It is visible, clearly visible to you all, right now? Okay. So now again, we will meet again on Monday online lecture. So again, as it is, it's my like tagline: stay safe, take care.
Thank you, sir.
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 Thank you, sir.